The vertices of a plane quadrilateral are labelled A, B, A dash, B dash in clockwise order. Let me draw this. Okay, that'll do. So we've got A, B, A dash, and B dash. Point O lies in the same plane and within the equilateral, within the quadrilateral. The angles AOB and A dash O B dash are right angles. So somewhere like this, maybe. We have a AOB and A dash O B dash. So these are right angles. They're not. This is not very accurate. These are right angles. And this is O. And OA equals AB. So these are equal lengths. And OA dash equals OB dash. So those two are equal. Use position vectors relative to O to show that the midpoints of AB, so we'll call this M, N, B, A dash, P and Q, form the vertices of a square. Okay, so if I just draw those in a different colour. Red. So we're trying to show that these form a square. So the first thing I suggest we do, start here, is come up with, right, let's call this, go black again, so call this vector A, this is B, this is A dash, and this one is B dash. So these are the position vectors relative to, position vectors are always relative to the origin. So A dash is the, for example, is the vector that goes through, that goes from O to A. Make sense? So this is just standard stuff, but just make sure that we're all on the same page. So OA equals A, yeah? Okay, so we want to know, I think the first thing we want to know is the position vectors of the midpoints. So OM, for example. OM is equal to, let's do OB plus a half BA. Okay? OB is B. From B to A is A minus B. So in total we have a half A plus B. Okay, so that's from the origin to M, to the midpoint of AB. And we can do the same for, what was that, OM, so ON, I think we can probably, because it's going to be the same, exactly the same process, it'll be A dash plus B. And then, so that was ON, OP. By the same argument, we would get a half A, so this is B dash here, make that a bit more obvious, A dash plus B dash, and OQ, which is going to be a half A plus B dash. Okay, so we now have the position vectors of the midpoints. Let's think what we're trying to do. We're trying to show that they form the vertices of a square. So I think we can do this by two things. Write down the plan. So point one is need to show that MN is equal to, so the length, I should say, of MN is equal to the length of of NP, which is equal to the length of PQ, which is equal to the length of QM. So we need to show they all have the same length. Two, need to show that QM is a right angle to MN, and so on for the rest of them. Right? Does that make sense? So we need to say that all of the lengths of the vectors to the midpoints, all of these red lines are the same length, and then also that we have right angles here, here, and here, and here. That will prove that everything is a square. So let's go on. And now we have all of the midpoints in terms of A, B, A dash, B dash. So now let's do one of these two. I think the first thing we want to do is find the vectors MN, NP, PQ, and MQ. So we want to find these red vectors. So let's start with MN. MN is equal to MO, we go back to the origin, ON. We go out to N. Does that make sense? So we start at, which is a different colour. We start here at M, we go back to the origin, and then we go out to N. And that's the vector. That's the same as the vector ON. Make sense? So MO is equal to minus OM plus ON. Minus OM is a half A plus B, and plus ON is a half A dash plus B. So in total we have a half A dash plus B minus A. I'm lying here, there's no B because the B's cancel. So it's actually, make that a bit neater, minus A. Okay? And I guess, can we work out the rest of them? So MN, I'm just going to do them. I'll do them one by one. So NP is equal to minus a half ON, so A dash plus B, plus OP, a half A dash plus B dash. And that gives, so they cancel, so it gives a half B dash minus B. And that was from N to P. P to Q is minus a half OP. So that's A dash plus B dash, plus a half OQ, which is A plus B dash. So they cancel, and we have a half A minus A dash. And last but not least, what was that? PQ. We need QM. QM. So that's minus a half OQ, which is right above me, plus B dash, plus a half OM, which is just A plus B. Equals, so they cancel, and we've got a half B minus B dash. Okay. These all have a symmetry about them, which isn't surprising at all. Right, so let's choose which one of these we want to do. Let's start by showing, let's do one. So we need to show that all of these are the same length. How do we do this? So one, let's do the mod of MN. squared, right? Why are we doing the mod of mn squared? Because if we have a vector and we want to know the mod of that vector squared, that's equal to the vector dotted with itself, right? So we're going to use the dot product here. So mn, the vector mn all squared, is equal to a half, so it'll be a quarter, a minus a dash, dotted with a minus a dash, right? Dotted by itself. So we have a quarter, we've got a dotted with a plus a dash dotted with a dash minus 2 lots of a dotted with a dash. So that is a dotted with a is the mod of a all squared plus the mod of a dash all squared minus 2a dash. Okay, let's leave that. Okay, hang about. So that's mod of mn, and it's also equal to the mod. So if you look down here, pq also has a dash in. So the mods are the same. So it's equal to that, and it's also equal to the mod of pq squared. Okay, all of these things are equal. Now let's do the other one. So we've got mn and pq. So what else do we need? We've got np and qm. So np squared is the same as qn squared, and this is equal to a quarter b minus b dash dotted with b minus b dash. And exactly the same argument as before, we end up with the same thing as the a's, but with b in the place of a. B dash, b dotted with b dash. Okay, so now our job is to show that these two are the same. So we know that mod of a equals mod of b, and mod of a dash equals mod of b dash, because it told us in the question. If we look back to the question, we've got these lengths the same here. So these bits are equal to these bits. Next, we need a dotted with a dash is equal to mod a dash cos of some angle between them, and b dash, or b dotted with b dash I should say, is mod of b dash cos of the angle between those. So now we need to show that the angles are the same. So the angles between a and a dash, if we go back to our diagram, the angle between a and a dash is this one. I'll do it in different colours actually. Is red, and this green one here. And we need to show that these two are the same. But hopefully that should be quite easy, because if we call, I'll do it in yellow, if we call this one theta, then the green one is theta plus 90. Actually, no, well, we called it theta now, and this one is theta plus 90. Okay, so now forget that I call it theta and call it something a bit more sensible, because I've already used theta. I call it alpha. So alpha plus 90, alpha plus 90. Right, so theta equals phi equals alpha plus 90, right? They're both the same. So therefore, A dotted with A dash is equal to B dotted with B dash. Yeah? Because these angles are the same. Okay, so we now have the mod of A equals mod of B. So this is the same length as this. We have mod A dash equals mod B dash, so this is the same length as this. Sorry, these should both be squared. And we also have these two are the same. Do this in green. These two are the same, which means that this one is the same as this one. Which means that the lengths of the length of all the sides are the same, right? So therefore all sides of same length. Okay, let's just zoom out a little bit, make sure that all makes sense. So the first thing we did was we determined what the midpoints were. Okay, that was here. Determine what the midpoints are. The second thing that we did was figured out the vectors for the midpoints here. Right? The third thing that we did was we showed that the square of the mods, the square of the sizes of these are all equal. So far we've shown that with this red square over here, or this red quadrilateral over here, all the sides are the same length. The next thing we need to do is show that we have right angles. So we need to show that these are right angles here. So I'll do this down here. So 2. So if we can show that they are right angles, we're done. So to show that they're right angles, we need to show that the dot product between them is 0. So right angles implies dot product is equal to 0. Again, this should be familiar from your normal A-level course. So let's look at mn dotted with np will do. Start with np. Mn was half a dash minus a, and we have a half. What did we say? NP. So b dash minus b. B dash minus b. So we get a quarter. A dash dotted with a. Dotted with b dash minus a dash b minus a b dash. These are all dotted. Plus a b. A dotted with b. Okay, we know a few of these. We know that. What do we know? We know that a dotted with b is 0 and a dash dotted with b dash is 0. So we know that this is 0 and this is 0 because we're told that they're right angles. So we're left with minus a quarter a dash dot b plus a dot b dash. And the next thing we need to do is show that this is 0. So if we look at the definitions of this, it's a dot b is a b cos of the angle between them. So I'll call them do I want to call them that? No, I'll make up new letters here. I'll call it capital A, will do. Plus a b dash cos b. And let me draw A and B. So A and B are the angles between A dash and B. A dash and B. So purple. So this one here is big A, and big B is the one between A and B dash. A and B dash. So this one is big B. Right. So we know that mod A is equal to mod B, and mod A dash is equal to mod B dash. So this is the same length as this, and this is the same length as this. So now we need to show that cos of, so need to show that cos of A is equal to minus cos of B. Why do we need to show that? Because if cos of A is equal to minus cos of B, this whole thing is equal to 0, which is what we're trying to show, right? We're trying to show that the dot product between them is 0. So cos of, let me just think about this for a sec, cos of, well, there's a relationship between A and B, right, which is that when you add them together you get 180. So A plus B equals 180, right? That's terrible, let me draw that again. A plus B is equal to 180. You just look at that, the whole thing is 360, and then you've got two right angles. So that still doesn't look like 180. There we go. So A is equal to B minus, no, 180 minus B. 180 minus B. So cos of A is equal to cos of 180 minus B, which is equal to cos 180 cos B plus sine 180 sine B. Cos 180 is minus 1, cos of B is cos of B, sine of 180 is 0, so cos of A equals minus cos of B. Okay, so we're done. Cos of A equals minus cos of B, so therefore Mn dotted with, was it NP? Yeah, NP equals 0. Yeah? So just to review that, zoom out a little bit. So I have already shown that the lengths of the midpoints are all the same. So Mn is equal to, mod of Mn is equal to mod of Np. Now I'm trying to show that when you dot Mn and Np together, you get 0. Right? Dot product is 0, and that means that there's right angles at each of them. So to do that, I dotted them, and then I used the definition of the mod here and here, and then we know that these are equal from the question. So now what we need to show is that cos of A equals minus cos of B, and then to do that I use the fact that A plus B is 180, and then just at the end you get cos A equals minus cos of B. So I've shown that when you dot them you get a right angle, and you can actually do the same argument over and over again for NP, PQ, PQ, and QM, because each time you're just dotting pairs of these. Yeah. So you've always got an A dash, a B, and a B dash. Same for this one when you dot those together. Yeah, you've always got the same pairs over and over again. So the dot product's going to be 0. So we're done.